In this video, we will learn about probability. We are mainly dealing with simple events. They are very basic questions. So let's begin. Here we have a problem where they have shown is a spinner which is divided into 10 identical sectors. So you can see 10 equal pieces are there in the sector, in the spinner, that are labeled as shown. The probability that the spinner lands on 3 is given as k by 10. We need to find the value of k. Before we begin this problem, let us understand one important thing. What is probability? Probability in simple terms can be told desired outcome divided by the total outcomes. Now, imagine there are 10 chocolates, okay, and there are 10 different flavors. Now you want chocolate flavor, that is cocoa, and now there's only one chocolate among the 10 which is of that flavor. So now what would you do? How much would be the probability to pick that chocolate? So how would you formulate the probability is basically your desired outcome. What do you want? The chocolate flavor, right? So that is only one. And how much are the total outcomes, the total possibilities? That is 10. There are total 10 chocolates. So the probability of you picking in random the desired chocolate would be 1 over 10, because the only one type of flavor you want among the 10 chocolates, and there are total of 10. So this is the thing. That would be 0.1 or 10%. So that is how we write the probabilities. So whenever you have any set of numbers or figures or like this sectors, you need to formulate it into desired outcomes and the total outcomes. Now then, what is desired over here? They have told it should land on 3. So the desired outcome is just 1, because the sector 3 in the spinner is just 1, right? And what are the total outcomes? The total outcomes are 10, because they have told over here 10. So all you need to do is the probability of the spinner landing on 3, that is P of 3, equals 1 by 10. Now the answer is 1 by 10, yes, but they have told not the probability, they have told the k value. That means they have told the probability of the spinner is given by k by 10, right? So this answer is equal to k by 10. So what is the value of k? So this one is 10 and 10. So k is equal to 1. So that is the answer. This is how we can solve simple problems like this. Now let's see another problem. There are 5 red, 3 green and 2 yellow apples in a fruit basket. Kevin picks 1 apple from the basket at random. Find the following. Now part A, the probability that Kevin picks a green apple. What is it? So let's see. First, red are 5, green are 3 and yellow is 2. So what do you want now? The desired outcome. The desired number of apples is green, that is 3, divided by the total number of apples. Add them all up. 5 plus 3 plus 2, that is 8 plus 2 is 10. This would be your probability in fraction. So it will be 3 divided by 5 plus 3 plus 2, and the answer is 3 by 10 or 0.3. If you want in percentage, then all you need to do is multiply into 100. You will get 30%. So this is the answer. But you do not need to write in percentage. Generally in decimal or in fraction would suffice. So then next one, let's see part B, the probability that Kevin picks a red apple. So same thing, but over here instead of 3 we have 5. 5 divided by so much. 5 plus 3 plus 2, and the answer is 0.5. Same way, probability that Kevin picks an apple that is not yellow. This is very important. It's not yellow. It's not just 2 by 10. They have told not yellow. So over here, other than yellow, both are not yellow, isn't it? So it is 5 and 3. So it'll be 5 plus 3. These are not LO, and the total number of apples that are 10. So it is 8 by 10. So these are the answers. Now, over here, they have told us to choose the same question, but they have given you plenty of options and you need to choose. Which of the following statement about this experiment is true? Choose two correct options. Let's read all the options and see one by one. It is likely that Kevin picks a green apple. See now, about likely or certain or equally likely. So as a thumb rule, it is generally considered that if it is likely, then it should be greater than 2 by 3rd probability must be greater than 2 by 3. Okay, sorry, x must be greater than 2 by 3. So that means 2 by 3 is 66%, about 66. Anything that is over 66% is likely. Now, if it's not likely, then it should be less than 1/3, that is 33%. And anything within this 1/3 to 2/3, that is from 0.33 to 0.33 to 0.66, it is equally likely. Or sometimes you consider 50%, that is 0.5 to be equally likely. Or if there are two equal amount of numbers, then that is also equally likely. So this is a little bit of gray area, but generally over here the problems are pretty simple. You can get an understanding about this. Now let's read them all. It is likely that Kevin picks a green apple. No, because there are other apples that are more in number. The probability is higher in them. So probability of green is just 0.3, which is no, wrong. It's not likely. Let's see the next one. It is likely that Kevin picks a yellow apple. So the probability of picking a yellow apple is just 20% or 0.2. So no, because that's only 2, right? It'll be 2 by 10 or 0.2. So no, this is also not likely. Then it is likely that Kevin picks an apple that is not yellow. That means it is 5 plus 3, 8 by 10. Yes. So that is 0.8 or 80% chances that there is these will be picked. So yes, this is correct. It is likely that Kevin picks an apple that is not yellow. It is certain that Kevin picks an apple that is not yellow. See, now this is wrong. Why? Because certain means it is 100% sure, at least over 99%. No, this is wrong because there's only 80% chance, or 0.8, that apple that is not yellow will be picked. So it is not certain. This is wrong. These were wrong. So they have told two correct options. So this must be correct. It is equally likely that Kevin picks a red apple. Let's see. Yes, it's 0.5. It is within the range of 0.33 to 0.66. So you can tell, yes, it is equally likely. So the third and the last option are correct. Now then, let's see another type of problem. A bag contains 20 cards numbered from 26 to 45. One card is drawn randomly from the bag and the number on it is observed. Fill in the blanks with the correct numbers. If a number is not an integer, then express it as decimal. Okay, so now they have told 20 cards are there, but the cards numbered from 26 to 45. It's not 1 to 20, it's from 26 to 45. And if you count them from 26th to 45th card, there will be 20 cards. Now, let's see what are the questions. The number on the card is less than 41. See, over here, they have mentioned it's less than 41. It's not less than or equal to, so you can't include 41. No. It will be less than or equal to 40. So you need to exclude 40. So this means 26 to 40. Because why? 41 is not included. It's less than that. So the number on the card is less than 41. So what is the probability for this? The desired outcome over here, the desired outcome is basically all these numbers. Let's count. You can either count from 26 to 40, or there's another easy way. What are the remaining numbers? It is 41 to 45. Just count 41 to 45. 41, 42, 43, 44, and 45. So there are 5 cards. So from 26 to 40, 20 cards are there, 5 cards are from left out. So how many cards will be from 26 to 40? It'll be 15. So why? Because the remaining cards are 5. So just deduct 5 from 20. Or if you're getting confused, just count from 26 to 40. You can count using fingers or anything. You will get 15 number. So you can just jump from 26 to 36. There are 10 cards. 36, 37, 38, 39, 40. There'll be 15 in total. So the desired outcome over here. So let's solve the part A first. The desired outcome is 15 number of cards. And what are the total number of cards? 20. So all you need to do is find the probability. 15 divided by 20, that is 5 table goes in these. It's 3/4 or 75% or 0.75. So that is your answer over there, 0.75. I hope this is clear. Now when we are answering the part A, just look over there. The number on the cards that is less than 45 has 15 outcomes. See, this is 15 over here, and the probability of its occurrence is 0.75. Similarly, you can pause the video now and try the part B by yourself. This is another simple one. Now let's look into this. The number, I hope you can pause the video now, try it by yourself, and then continue. I hope you tried pausing it. Now we will look into the answer. The number on the card is a multiple of 5. Now multiples of 5, that means 5 tables. 5, 10, 15, 20 and goes on, right? So can I have 25 in this? No, because the numbers start from 26. So this is wrong. Let's start from 30. 30, 35, 40 and 45, because even 45 is included. The numbers are till 45, right? So there is 1, 2, 3, 4. There is 4 outcomes. And what is the probability of occurrence? 4 divided by 20. And we just need to simplify it. So over here, the numbers that are multiple of 5 are 4. You can see 30, 35, 40 and 45. And the probability of multiples of 5 are 4 divided by 40. Sorry, 4 divided by 20. That 4 one time and 4 goes 5 times in this. So 1/5. 1/5 is 20% or 0.2. So that is the answer, 4 and 0.2. So this is how you can solve this type of problem. Let's see another one over here. A man has 31, this should be black sheeps, I believe, black, 49 white and 20 brown sheep. Sorry for the typo over here. Fill in the blanks with the correct decimals. So let's see what are the questions. Part A, the probability that a randomly selected sheep is white, and it is equal to how much? So now let's see. What is the desired outcome? Desired outcome white, 49. What is the total outcome? You need to just add them all. So 31 plus 20, 51, 51 plus 49, it's 100. So it is 0.49, 49 by 100. Now same way over here, you need to select not white. Let's see one by one. The desired outcome over here is 49 for the part A, because we are choosing white sheep. And then probability of white sheep is 49 by 100 or 0.49. Now for the part B, over here, a randomly selected sheep is not white. So it is basically other than this white, 31 plus 20. So that is the not white sheeps, right? So it should be the black or brown. So it is 51. And okay, again it's wrong. It should be not white. This is not white. I apologize. So this is not white sheeps. That is 51 divided by the total number of sheeps. That's 100. So 51 by 100, that is 0.51. So it is very simple to solve these problems. Just see what they are asking you for. then write that as the desired one, and then you must just count the total. Just desired divided by the total, desired outcome divided by the total outcome is the probability. Now, another type of problem, the last one in this part. A set of cards with a letter printed on each as shown below are placed in a bag. Andy picks a card from the bag at random and records the letter printed on it. See, these are the things. Statistics, STATISTICS. Enter your answers in fraction in simplest form. Now here, for the part A, they have told what is the probability that Andy picks a card not labeled with S. So now, not labeled with S means everything that is other than S. Let's count the numbers, and another one is which are not labeled with consonants. So we'll come to both of this. First one, not labeled with S. Don't be confused when it's not something. Not something is, see now S's, they just see where is all S, over here, and over here. Leave them, not S, right? Leave them and count all the others. So it's 1, 2, 3, 4, 5, 6, 7. So the desired outcome would be the card not labeled with S. The total desired outcome is 7. And what is the probability of not S? That is 7 divided by the entire numbers, the total numbers. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3. It's 7 plus 3 because there are 3 S's and there are 7 non-S's. So it's 10 over here. You can count them up. So that's the probability, 7 by 10. And they have told over here in fractions, write them in fractions. So don't write in decimals. This is the fraction. Decimal means if I write 0.7, this is decimal, but leave it in fractions because they have clearly mentioned it. So that is the part A answer. And now for the part B over here, what did they ask? They asked not consonants. Now what are consonants basically? Consonants are not vowels. So there is vowels. Sorry, that's A, E, I, O, U. And then other than these letters, all are consonants. So now here you can see there is vowels 1, 2, 3. There are 3 vowels. And now they have told not consonants. So these are all consonants, right? These are all consonants. So not consonants means vowels. It's simple as vowels. You should just find the probability of vowels, but instead of giving it directly, they have told not consonants. So the desired outcome would be all the vowels, that is 3. The card that not labeled with consonants are 3 because it is only A, I, and I. And what is the probability of this? It is just 3 by 10. So this is the answer. And this is how we can easily solve probability problems. And these are just basic probability problems. In the coming videos, we will do even more complex probability problems, hopefully.